Hi, welcome to another Level 3 Probability Concepts video. We're going to link probability and graphs together. When data is collected, it can be modeled by a probability distribution. A distribution can either be a graph or a table. So let's have a look at this graph. It's a bar graph and it has frequency on the y-axis. But the same information can be drawn like this, where we have the probability or the relative frequency on the y-axis. Here's our table with all our outcomes, probably rolling a dice from 1 to 6. And for a frequency graph or table, we're going to put frequency in here. How many times did we get the number 3? How many times did we get the number 5? It's called a frequency table or frequency graph. But when we have the probability on the y-axis, we're going to change the y-axis to probabilities, and we can call it a probability table and probability graph. Also has some other names, probability distribution table and graph, or relative frequency table and graph. All right, let's go through a couple of examples. If a student is selected at random from this sample, what is the probability the student was born in a month with only 30 days? Well, I always forget how many days in each, so I use my hands to help me remember. The months of April, June, September, and November have 30 days. So here are these 4 months, and if I add them up, we have 3 people in April, 10 people in June, 7 people in September, and 4 people in November. And then if I add up all the other months, I get 64. So the probability is 24 out of 64. You could leave it like that, or you could simplify it or turn it into a decimal or a percentage. What about this example? If a student was chosen at random from this class, what is the probability they were between 160 and 170 centimetres? Well, these people here are between 160 and 170. So there are 3 people between 160 up to 165 and 1 person from 165 up to 170. So there's a total of 4 people. Once again, I've added up all the other bars, the heights, and I get 20. So 4 out of 20 are between 160 and 170. And again, you can simplify it or turn it into a decimal or a percentage. All right, example 3. The following data shows the result of a quick test out of 6 marks for 20 students in Mr. Pythagoras' mathematics class. We're going to put it into a probability distribution table. Let's show you how we did this. So you can see 2 students out of the 20 scored 0. 2 out of 20 is equivalent to 10% or 0.1. So the probability a student got 0 was 0.1. There were 7 students out of 20 that scored 4 in the test. 7 out of 20 is equivalent to 35% or 0.35. So the probability a student scored 4 is 0.35. Now, it's useful to quickly add up the probabilities to make sure they add up to 100% to check the table is correct. Okay, so here is our probability distribution graph from the table. So it's called a probability table or graph, a probability distribution table or graph, or relative frequency table or graph, different names. Okay, so can you see that the probability of scoring 3 is 0.2. 20% of students scored 3 in the test. The probability of getting 5 in the test is 0.05. 5% of the students scored 5. All right, here's the question we're going to ask. What is the probability a student scored less than 3 in the test? Less than 3. Well, these are these options, and you can either read off the table straight if you have the table in front of you, or you can look up the values in the graph and add up the values of 0.1 plus 0.15 plus 0.05 to get a probability of less than 3 being 0.3 or 30%. Great. Thank you so much for watching the video.